Summer in the hills, those hazy days I do remember. We were running still, had the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand, open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
Okay, good evening everyone. Let's see if this works and if I can hear myself or ourselves on YouTube, then we can get going. Yes, it's perfect. So, today's guest is Robert. Robert is, well, a lot of things. First of all, he's the author of... Human, yes. First of all, he's a human. Second of all, he's the author of NsJail, which is a Linux sandboxing solution. Also the author of HongFuzz, which is a fuzzing fuzzer basically, which uses top-notch CPU features, which is quite unique and pretty amazing. He was also my, and still is my mentor at Google, so I'm very grateful for that. And also a member of Dragon Sector. I don't know, do you want to add anything else to that introduction?
What I can say, I guess I'm living in Switzerland for 10 years, which precedes Genval for like 3 years, right?
Yes, that's correct.
Yeah, so... And yeah, I like it in here.
It's perfect, I like it too. Okay, so today we were going to talk about NsJail and sandboxing in Linux in general. So if you have any questions at any time, then please ping our moderator. The moderator today is this guy. His nickname is here, KrzaQ. KrzaQ will take your questions and pass them to us using the means of thought teleportation, I guess, or some backend stuff we have. Anyway, before we get to that, a couple of announcements. First of all donations today, if any, will go to the charity of Robert's choice. So yeah, feel free to donate. Second of all, the Gnveil's Winter Game Dev Challenge has been completed, which means that the results are available on my blog, so go check them out. The games were pretty amazing, and I really enjoyed testing them. So thank you for participating, and thank you for the interest if you voted in the community award. And yeah, I guess summer is going to be, I'll be hosting another competition like that, so it should be quite interesting. Okay, and yeah, I guess we can start with a question, but before we get to the question, one more thing. If you're interested in C++, then visit KrzaQ's website. He is our moderator today. Again, thank you, KrzaQ, for being here and helping us. So yeah, do visit his website, and KrzaQ, you should totally write more on your blog, which I guess I'm repeating every time. Cool. I guess we will get to this in a second. Let's start with answering this question from Blood Sector. Which book or course you will recommend for binary exploitation? I guess this question is for you. Okay.
So actually I have no idea, because I think I've never read any books about binary exploitation. I'm sure they appeared, like they started to appearing for the last 5 years maybe, or something like that. But I guess I was first exploiting things, like obviously first simple things, maybe 10-15 years ago. So I guess when they started to popping up, I knew this stuff, and more advanced things started to popping up again, but I was maybe a little bit more advanced. So I've never really read anything which can be called as a book, right? So there are interesting technical papers which you can read when you are exploiting things for a longer period of time. Like for example, read things about rope chains when they appeared and so on, right? I think if you speak Polish, obviously, right? There is this book of us, Applied Reverse Engineering, which a little bit touches the topic. There is at least 1 or 2 paragraphs which are about binary exploitation. So yeah, if you are speaking Polish, take a look at this. Otherwise, I'm not sure. Maybe you have some ideas.
No, not really. I mean, when I guess my story is like similar to Robert's, as in when I started, there were some books like Shell Coder's Handbook, something like that. Then there was another one which I'm pretty sure I have on my shelf, but I cannot remember the title. Sorry about that. But that was 10 years ago-ish, maybe even more. And these books are now a little outdated. 10 years ago, you were dealing with 32-bit systems, and currently, 64-bit is the default, right? If you go to any CTF challenge, you will see 64 bits, and, well, at least on most of them. So it's hard for me to recommend any title. That being said, this is also because while I buy a lot of books, I also, well, don't really read them. Maybe somebody on the chat has a good idea. So if you have any ideas for book recommendation on binary exploitation, then please, by all means, do recommend them on chat. So, yeah.
Though I'm like really certain that there are good books. With the amount of people playing CTFs and doing good research, and you can see them at Black Hat or other conferences, I'm sure there are very good books these days. Just, I haven't read them, I guess.
Oh, for example, Corlan exploitation tutorials. That's one recommendation I see on the chat already. Good question. Okay, I mentioned this already. Before we get to the next questions, let's do some of the planned stuff. First of all, I'm going to recommend you seeing or viewing watching Robert's talk from Confidence last year. It's already last year, time flies. It's about sandboxing in general on Linux, and also touching on related subjects. KrzaQ is going to give you the links to both the video and the slides, we'll be discussing some of the similar topics today, which are there, but also extend this to NsJail. So yeah, just wanted to be sure to mention that. So okay, let's I guess, Robert, let's start with the basics. What's sandboxing? I mean, so I know it's actually the place where you play with sand and you can, you know, you have a shovel, and is that it?
That's true. That's completely true. So yeah, it touches a little bit about philosophy of computing, but when you run something which is potentially untrusted, and by untrusted I mean something which cannot be, for example, reviewed by you. Like you cannot take the source code and take a look and make yourself sure that it's not something that will do something that you don't want it to do, right? Or you are buying something in only binary form, or maybe something is progressing so fast, like somebody is providing updates to the source code so fast that you cannot like cope up with reviewing this stuff, right? And then you are not sure that such software will do what it's intended to be doing. And at that point, you will start looking for a solution which will make that software do whatever it's intended to be doing and nothing exactly else, right? Modern operating systems are allowing for a lot of things by default. You can connect to any host on the internet if your box is connected to the internet, and like every box these days is connected to the internet, right? You can interact with all the processes which are running with the same privilege process. In Linux, it means the same user ID, for example. So we are looking for, as a sandboxing, we are calling a solution which will do exactly this: shrink privileges of your process to only these exact operations which are required by this software and nothing exactly else.
Okay, so that's a good description. So basically it's supposed to be a kind of an additional boundary or a layer on top of an application, which the application is untrusted. And, well, the application should not be able to do anything else than it's designed to do. Perfect. So, okay, what, like, for example, when I've entered the whole security business, the most, the thing on the top for sandboxing was Chroot. So what's Chroot, and is it a great sandbox?
Well, obviously, if you are interested a little bit in computer security, you've probably heard or read about Chroot and why it's not secure, right? Because Chroot was never meant to be a security boundary. It started to be used by some people as that, but originally it was used for other purposes. It was like for testing new software in a copy of your your file system, right? Like you could.
So the name is from change root, right?
Yes.
Chroot or Chroot. Yeah.
So maybe you wanted to test your new libc library, right? And you didn't want to change your main libc because it would be kind of tragical if everything stopped working. So you could put it inside some directory and then change root, and then dynamic linker, which is looking for libraries, will pick up this library from this changed root, right? But kind of quickly people figure out, yeah, why not use it, right? It doesn't have too many drawbacks. Like if there is nothing else you can do, absolutely nothing, using Chroot gives you something. Like if somebody gets remote code execution in your binary, that person will be at least limited to your very specific directory. Granted, there are usually many escapes about Chroot. Some are by design, some are kind of accidental. For example, in Linux, let's assume that in Linux you are exploiting a binary which is running inside Chroot. Now you have remote code execution. You can use any debugging interface, something like Ptrace, for example, to attach to any other process which is not running with Chroot, and you escape the Chroot. You change other process memory, it does what you want. There are also some kind of by design Chroot escapes. If you are inside Chroot and you can Chroot yourself, again, it means that you can escape Chroot. I would probably like, if I try to explain it how it's achievable, it will come out as a big spaghetti of words. So it's better that you look on that on the internet. It's like basically if you are Chrooted, then you shouldn't be allowed to Chroot again. It's basically automatic escape from Chroot. So that's why Chroot was never meant to be a security mechanism. It was only used in the absence of other things. And actually, some some big big pieces of software used in this internet here are still using it. I think IC bind are using it, and I think SSH prefset process is using it.
Okay, cool. So basically chroot only triggers the file system view of the process, right? Or does it do anything else apart from the file system?
I'm not. It would, in the description of Chroot, I don't think there is anything else. Maybe some operating systems are adding a little bit of their own inventions, what you are limited to doing about Chroot. But honestly, I don't remember what POSIX says about that. It's only like when you request a file, it will be requested. Like if you ask operating system through a syscall, give me this file of this given path, like this prefix, this change root prefix will be appended to it, and the file will be opened.
Okay, so that's it. So basically, as you mentioned already, Ptrace can be used because there is no PID namespace, and
you can send
network
signals.
Okay, network isn't isolated in any way.
Yes, for example, in modern Linux, you have like there are proponents and opponents of things like systemd and those new daemons, right? There are big wars fought about it right now, and they are daemons. For example, dbusd, which is this inter-process communication pipe inside modern operating systems. And what is attached to those dbusd are interesting processes. There are, for example, processes which can allow you to run processes on Sandbox, like by design, right? For example, I believe there's GNOME terminal. The GNOME, when you click on the icon of GNOME terminal right now in Linux, it's not that the new process is created by the operating system by executing user bin GNOME terminal, but a request to the current GNOME terminal is sent, and the same process is basically opening another window for you. So if you are sandboxed by, well, in quotes, sandboxed by Chroot, you still have access to this dbusd. It's running in something called abstract socket namespace. You don't need to have access through it through the file system, and that's why you can simply ask GNOME terminal, hey, open a new window for me, and maybe even like send some keystrokes to it, right? It's like perfect sandbox escape. So Chroot is it gives you a little bit confidence in the absence of other mechanisms, but
so not recommended.
No, not alone. Not for CTFs, right? Not so for CTFs. No, not if you are like big, well, even small company processing sensitive data. So no.
Okay, let's get through the questions, and then we'll get to the next mechanism. So Przemysław writes, again, I guess it's for me. If you remember KrzaQ vulnerability in WPA2, I want to ask you, how serious is this vulnerability? If some of my devices are not patched for some reason, is it dangerous? I don't fully remember the vulnerability. If I remember it correctly, though, there were a couple of variants depending on how deep the implementation problem was, and there was one variant where, for example, you could reset the key to be zeros, just zeros, because it didn't implement whatever feature they were using, and in that case it was super bad because you could both listen to and inject traffic. In other variants, if I remember correctly, you could only inject traffic in some cases. So it's great to be patched, but I don't think it's critical. That being said, I don't remember it fully. Please look into the white paper and actually, well, check there. Do you remember some more details?
No, nothing more. Just like passive interest, I guess.
The best supervisor writes, why did you write it in C? Did you need the speed? Why not Rust? And I guess it's a question about NsJail.
Okay, so I'm not sure if Rust was there when I started writing it.
Maybe it just began, but it wasn't popular at the time.
2000, maybe 13, 14? Probably it started.
That's actually, I'm going to check, like, when did Rust come in to play. Rust programming language. Okay.
Maybe it started in 2005 and nobody picked it up, and then...
No, it's first appeared in 2010. Rust appeared in 2010, so okay. But I guess it was slowly gaining popularity. So
there was Go at that time, I guess.
Go was 2009. Yes.
Yeah. So yeah, obviously, when I started writing it, I really needed some interface to the operating systems. I really needed to call a few syscalls, prepare some environment, and if you looked at the GitHub repository and when you look at the first version, it was really like one file tool, which was basically enabling a couple of namespaces and then running your program. See what was all I needed. There is also not really a way to there is not big attack surface on NsJail itself. NsJail itself only prepared the environment for a process and then runs this process inside this environment. And then, yeah, NsJail parent runs somewhere, but it's another namespace, you cannot interact with it, so there is no really attack surface. So I wasn't that concerned. Though, interesting thing about Go, so you probably heard about it. So Go is by default, I believe, multi-threaded from the very beginning. And it runs multiple threads, and the execution context, what I mean your program, can jump between threads. And it's not good for systems programming. Sometimes you are directly depending on the fact that you are waiting for a sub-process from the same process that you created it. Or for example, you have Ptrace interface. I'm not using it in NsJail. But if you start Ptracing something from the Go process and then later wait for event from it, you might not ever receive it because your execution jumped to another thread and this thread is not waiting for anything. So all those languages, I'm not sure about Rust, I haven't worked with it, they are a little bit too smart to program such low-level interfaces like Sandboxing in Linux. So it's the best.
Yeah, so just to address something I see on the chat, namespaces are not C++ namespaces, so this is like namespaces thing in kernel. We will get to what are namespaces.
Yeah, we can troll they are for like half an hour.
True. Okay. Okay, that's that. Would you be able to share the papers on heap-based binary exploitation after this live stream? I really can't find any good papers, and it seems like there are really less papers. Do send me an email. I actually have a list of the papers for heap exploitation, so yeah, which I got from my viewers, so I will pass it on to you.
I can only add to that, there's this couple of papers from 2010 or something, House of, right? They start with this name, House of Force, House of Tears or something like that, and they tell you how to exploit malloc heap from GDPC. And all those mechanisms except I think one doesn't work anymore. And actually at the CTF in China, it was one of the biggest CTFs, WCTF. It was required to use this House of Force, I believe, heap exploitation. But they are all starting with this prefix heap of House of something. Look for it.
Yeah, that's a good tip. Okay. Is Docker a sandbox? There were a lot of questions about Docker, so we're probably going to talk more about it, but is Docker a sandbox?
That's a shame, because I'm not really into Docker. But by necessity, I need to know something about it, basically what it's not. And as Docker initially was implemented as a portability toolchain, like write a software once, compile it even once, and then distribute it on many operating systems, given you will have the same access to the same libraries and so on. But people very quickly spotted that it can be used for isolating software, and there is problem with that. So Docker by default doesn't shrink kernel attack surface. So in Linux you have syscalls, right? Syscall is a way to interact with the operating systems besides using the CPU resources and memory which is allocated to it. When you open a file, you need to ask operating system, open this file on my behalf, right? There will be some permissions checking and so on. And then operating system will open this file for you or not. And there are right now around 350 or something syscalls for x86 Linux. And they expose enormous attack surface. So you have simple syscalls, something like sleep for me 5 seconds. You cannot probably make big mistakes with that in implementation, but they are crazy syscalls. Like Ptrace is one example. It's a debugging interface. There are syscalls which are which can perform on your behalf copying memory between processes. If you look at their implementation inside the kernel, it's enormous. These are like thousands, hundreds sometimes of thousands lines of code. So when you are using Docker, with a few exceptions, you are at freedom to interact with all those syscalls. And any year, you will get at least a couple of kernel privilege escalations bugs. You probably heard about such terms like dirty cow or something like that. So if you are using Docker, you are basically betting on the fact that the person who exploited your binary and got remote code execution isn't smart enough to find another exploit for the kernel. And as I said, there are at least couple good reliable exploits per year, and maybe a couple which are not, exposed by their authors because they are working for some shady security agency or some kind of gang with, maybe not gang, but yeah, security agents.
Yeah, so people who like to keep their exploits in a drawer for a reason.
So it's a gamble, but also a gamble with a knowledge that there are bugs. And if you want to spend some time, you will find a bug. I found a couple in my lifetime, and it's possible. It's possible.
Okay, so basically, Docker still has this kernel syscall. All the syscalls are available for every process, and therefore there is no isolation on that layer.
Yes, Docker, last time I checked, and I checked like 1 year ago, they are by default blocking a couple of syscalls by, I believe, Seccomp mechanism, but they are doing it in a way that it wouldn't harm any binary which is running in it, right? They are blocking, I think, maybe I'm not precise enough, but at least a couple of syscalls. One of those syscalls is, for example, personality syscall, which is used for some interesting purposes, but probably not by any reasonable software. So they are blocking this. And this approach is called blacklisting, and blacklisting usually don't end up well in security.
It's true. Okay, so yes, as I mentioned, we'll touch on Docker later. What do you think about the idea of an operating system with a JavaScript VM in ring 0 under one addressing of a thin layer of C? VM provides security, Electron apps become native. That's a question from Michał. What do you think about it?
I guess Michał is talking about some real world thing.
Is there such a thing with JavaScript VM in the kernel?
I need to put it in my head what it all exactly means. So basically we have regular operating system, and inside this regular operating systems we have additional JavaScript virtual machine.
Yeah,
I guess
the idea is that you have whatever you need to be in assembly and C, you have an assembly in C, but everything else is just JavaScript.
If you just take Linux and put JavaScript virtual machine into ring 0, that's an enormous attack surface. As an example, we had those recent bugs like Meltdown and Spectre found by our friends at the company. And one exploitation vector was using BPF virtual machine.
Yeah.
Berkeley packet filter. It's kind of old technology from 90s or something like that. It was used for TCP dump. When the kernel wasn't that fast, you can upload this small bytecode inside the kernel, and you can tell the kernel, hey, give me only packets which are matching this BPF Berkeley packet filter code. And in 2010, Will Drury from Chrome OS thought that it would be a good idea, actually it was a good idea, to reuse this BPF for security. So we have Seccomp BPF right now.
Which we will talk about later.
Exactly.
Also, it's on the list.
And when we got to this, finally to this Spectre and Meltdown attacks, actually this BPF functionality, which is a small virtual machine, it's not very complex, was used actually to do interesting stuff in the kernel. So even such small virtual machine allows you to do big harm.
Yeah.
And such big virtual machine like JavaScript is crazy.
So was it BPF or was it eBPF? I think that's like some extensions for BPF. I don't know how it exactly works.
Originally it was BPF, Berkeley packet filters.
Yeah,
BPF came later, 2012, 13 or something like that. eBPF is not used with Seccomp for security purposes. I believe eBPF is mostly used, although I haven't looked at it, into things like tracing the kernel, also some networking ideas. Yeah, I need to look at it more, I guess.
Yeah.
But
So
not for Seccomp.
kind of following up on the idea, so that's one thing which Robert mentioned. The other thing is JavaScript wouldn't be the most secure language I can think of, as in, so I like to look at programming languages like this. Is the given language, can you, in the given language, easily write secure code? And JavaScript, the answer is no, because JavaScript has crazy ideas with types, and with comparing types, and with doing casting between types and some other stuff. So I would be afraid of that. There are languages like, by the way, C++ is also on that list, but like next to PHP and JavaScript on my list. C++ is not a language where you can easily write good code. And C is also somewhere there, sorry. That being said, yeah, there are ideas like that, like Singularity, for example, from Microsoft. I think somebody mentioned already on the chat. That was in C#, that might have been a little better. So the idea of putting higher level code in the kernel isn't new, but there are some problems with it, especially that the models of the higher level code, and I mean languages like execution model and memory model, don't really fit well the hardware level. Like C model barely fits it, and we have to sometimes work around it. So I'm not sure that's a great idea, but yeah, I mean, it might be the future anyway.
On the interesting part of the things is that Linux kernel is written without floating point, without basically floats inside.
Which is a good thing, I think.
And JavaScript is all about floats.
Yeah, the number type is double.
It's not saying that current CPUs wouldn't be able to run it. It's just conceptually right now problematic to put it inside Linux. If you are talking about Linux kernel, because I'm not sure if I understand the premise of the question.
But I agree. I mean, in JavaScript number type, which is the basic type, is another problem. Cool. Okay, there are like 1 million questions, I think. Rust 1.0, KrzaQ says, was in 2015, so that's when the first stable version of Rust appeared, 2015, so that's way after you already created NsJail, I guess.
So I'm working with other people inside company, outside company on sandboxing things, and I can assure you that inside this group of people that I'm working with, they are like devoted people to either to Rust or Go, and we are sometimes fighting holy wars in which language sandbox should be written. So yeah, I was talking a lot with proponents of Rust and proponents of Go. So,
but see it is. So you have no plans as of this time to rewrite NsJail in Rust?
JavaScript.
In JavaScript, okay, perfect. Okay, I guess we can touch on this question. What's the main difference between NsJail and FreeBSD's jail? We were wondering if this question will appear.
Okay, so I have only passing knowledge about FreeBSD jail. I have a good friend who is having a fleet of machines based off FreeBSD, and he was always shooting me a lot of information about how it works and so on. If I remember correctly, FreeBSD jail works kind of similar to Linux namespaces, but it, for example, requires of you that you dedicate at least one IP address to it. So that's one thing. The other thing, I believe, I'm not 100% sure because my knowledge is from like 10 years old, I guess. You need root to start them in FreeBSD. And what else? Well, if we are talking about differences between Linux namespaces and FreeBSD jail itself, then conceptually some ideas are kind of similar. You can achieve more or less the same type of isolation, right? You basically ask the kernel, like, now I will have a process or pool of processes which will be somehow disjoint from the rest of the operating system. But NsJail itself gives you a few more things. For example, it allows you to apply those Seccomp BPF policies that we can talk later about. And I'm not sure what kind of syscall limiting facilities FreeBSD offers these days. I think this is Capsicum and maybe Pledge from OpenBSD. Somebody would have to enlighten us on that. But yeah, FreeBSD jails offer more or less this functionality as Linux namespaces, I believe.
Okay, cool. So let's get one more question and then take the next subject from the list, and then we'll return to the questions later on. Przemysław writes, do you both think that that's it better to apply all security patches to all possible software as soon as it's possible by normal means, or wait to check if there are no regressions of the fix? What's your take? Should we patch as quickly as possible, as I think I've mentioned already today, or should we actually wait and see what happens?
Maybe it depends on the size of the patch, right? Sometimes you can understand the patch and say, yeah, obviously that's a good patch, right? But with those latest Meltdown and Spectre, that's interesting, right? Even big companies like Intel, which are having presumably hundreds of engineers, which are spending their time on finding good non-CPU intensive solutions to those problems. They can release a firmware update or recommend some solution for the operating system, which turns out to be not good after 1 week. So the first criterion that comes to my mind is the size of the patch and your ability to understand it, basically, right? Sometimes it's a patch for buffer overflow and you can just see, yeah, that patch fixes it in this way. But when Intel microcode problem comes into play, then yeah, who knows that, right? Only Intel engineers.
Exactly, like the microcode is both encrypted and signed, and you cannot really look at the patch, and even if you could, it would be probably a little more esoteric-ish or exotic to analyze it. So I agree. What I'm going to add to it is that there are cases where you would, well, we don't review patches, right? Like, for example, for Windows, you probably are not looking at every patch which comes because it's a huge binary blob. Of course, if you're into Windows security and you want to know what was patched, then you probably are looking at it, but in the end, most users are not. And there were problems with, I had at least like one bug we had with Euro, which Microsoft patched, and it turned out that in Brazil, there was an local antivirus which blue screened after the patch. And it's, it's unfortunate if you're a company administrator, you apply patches and that happens. So yeah, so I guess it's a risk analysis, like, in the end. For example, if you can understand what vulnerability is being patched, you can understand what is the risk of actually being prone by it, and maybe there are some workarounds, and you can delay the patching by 2 weeks and see, like, if anyone else has any issues or problems with it, or maybe there is a backdoor inside the patch, like somebody just got access to the repository for 1 hour, like did this, and this, and suddenly there are backdoors all around, and they were shipped out to customers. I'm just saying that happened in the past, but it might have happened. So, yeah, so that's also like another thing which would make you want to wait out patching. Yeah, so it boils down to risk analysis. If you can have some workaround and know that, hey, this is probably okay if we like block these ports and like sandbox this application, we can wait it out for a couple of weeks. Other than that, it might make sense to just patch it, especially on like home computers, I guess, because it's like, if you have reinstall Windows on one machine, that isn't a huge problem. If you have to reinstall Windows on 1000 machines in your company, that is a problem. That's my take on it.
Yeah.
Yeah. So yeah, a perfect non-answer.
A lot of words for.
Yeah, a lot of words for saying
it
maybe. It depends. Yeah, that's true. Cool. So moving forward, let's get back, as I mentioned, to the topics. So we mentioned Chroot already, or Chroot. Then Ptrace. Ptrace you mentioned already today as a debugging mechanism. So can you tell me more about what's Ptrace and how can you apply a debugging mechanism for sandboxing?
Sure. So yeah, at some point, I'm not sure if Ptrace is originally Linux interface or it was, in quotes, stolen from some other operating system. That kind of interesting question. Yeah, but it appeared in Linux as a debugging interface. So basically, when you run GDB, when you track real process, when the GDB, for example, reads values of some variables from your process, it uses Ptrace mechanism. Ptrace is like Swiss, pun intended, mechanism in Linux, like a Swiss knife, and it allows you to do anything with remote process basically. So you can read memory from it, you can write memory to it, you can read registers, write registers, read floating registers, you can read signals which were delivered to the process, you can send your own signals, you can modify many things out there. And one of the functionality of the Ptrace interface is basically to enter the process in something which is called syscall stepping mode. So before syscall stepping mode, you probably know that every CPU, or most of the modern CPUs, has mechanism which is called single stepping by itself, right? So we are basically moving one instruction forward, right, or one branch forward, depending on the CPU. And they figured out that Ptrace interface can allow you to do the same with syscall on syscall basis. So from time to time, processes are invoking the syscalls, which is to say they're asking operating systems do something for me, because process itself cannot do anything else than use CPU and write and read from the memory. That's ideal situation. And when such process asks operating system do something for me, then the operating system takes control and it can inform such debugger like GDB via Ptrace mechanism that this process wanted to do something, and here are the data describing this kind of event. And people around 2000, I would have to check that, but I think it's 2003, 2004, thought, hell, this is kind of good for sandboxing, because what we can do right now is to make the process into syscall stepping mode, and when the syscall happens and the operating system tells us, hey, syscall happened in this process, we can examine its basically registers and memory to see whether it's something we allow or not. You remember from the beginning of our conversation that sandboxing is a way of making process to do only the things we want it to do and nothing else. So we can actually do this kind of analysis of the process. So if the process invokes a syscall, let's call it open, it wants to open some file, you can take a look at the registers. And outright, just like that, by looking at the registers, you can see whether this open was requested in read-only mode or write-on, or read-write or write-only mode, right? Or create mode. And maybe you allow only for your sandbox process to open files in read-only mode. So you can very quickly, by looking at the registers, tell whether it's a good request or not. If it's not, you can do some action. Typically, it's kill the process and maybe inform administrator of the system that something scary had happened. When in fact you want to have a whitelist of files which you allow for such process to open, the game becomes a little bit more interesting. So if you were looking at any time at the syscall interface, it can only pass integers in registers. It can pass integers and pointers. And when you invoke OpenSyscall, it doesn't pass in the register's name of the file, it basically have it in its own memory. And what it passes to operating system is basically a pointer to its own memory. And now Ptrace was also useful because you can see when this register is pointing to, you can read the name of the file and basically match it against some whitelist of files that you allow or not. And basically, in consequence, do the same thing. Either allow it or kill the process and inform the administrator, or log it, or scream loudly, basically.
Raise alarm, okay.
But yeah, obviously, drawbacks of Ptrace. It was never meant, at least from the very beginning, to be a security mechanism. It was only a debugging mechanism. So this idea of like syscall to syscall tracing was implemented in kind of bad way. So you were getting information from the wait interface that some debugging event had happened, and you got the same information about syscall enter and syscall exit. So you had to keep track, like, which syscall enter is that, which syscall is it syscall enter, syscall exit, syscall enter, right? If at any point you made a mistake, then you were treating exit as enters and the other way around, and obviously it could lead to big problems. And one of such attacks, actually it was kind of first attacks on the Ptrace sandboxers, was that you can, at least under Intel, invoke instruction called int3, which is a debugging instruction, something causing debugging interrupt, right? You are the master of x86.
Yeah.
And at this moment, the debugging event was delivered to the supervisor of such Ptrace sandbox, and typically Ptrace sandbox didn't have any means to figure out what was that, whether it's a syscall event or some debugging event like int3. So basically at this point, this subtle change can happen, that you were starting treating exit as enters and enters as exit. So okay, and people were thinking hard how to do that, and there was some mechanism invoked on how to do that. For example, you could actually read the instruction which caused this debugging event, and if it was int3 or anything else then not int80, then you obviously again scream fall and kill the process or something like that. But it all started becoming very slow, right? Like stopping a process at every syscall and reading contents of its registers. Yeah, okay, we can read with that, we can live with that. But additionally, reading memory to figure out what's the instruction that caused such event, it becomes slow, right? And it's not the only problem that existed with Ptrace.
Okay, so you have basically two processes, right? The debugger and the debuggy, and you have to, like, at every syscall, you have to basically do a context switch from one to the other and back. And that's twice per syscall.
Yes, enter and exit, and it's not even configurable. Like, people who were implementing Ptrace thought that the hell, it's like debugging interface. You don't care how fast your process executes syscall when it's under GDB, if you really want to see the syscalls, right? So yeah, it was slow, and it was problematic, and it was kind of insecure. And for the record, the first Ptrace based sandboxer that I know of was created by Niels Provos, a person who is also working in our company these days, and it was called Systrace. So you as a part of history of sandboxing, you can take a look at it and its implementation. So that was it. That was the first sandboxer for Linux that I know of, which is not based on Chroot. And people started using Ptrace for sandboxing like hell, like everywhere in different companies. And they started demanding from authors of Linux to implement more features which are security-wise around Ptrace. So over the years, you can find in the kernel changes which are, for example, adding ability to figure out whether something is actually syscall or some other event, right? You can, for example, there were added features which allow you to make sure that if your supervisor, this process which checks the policy, exits, also all trace processes exit as well. Because it was also a big problem, right? Like, you were writing a supervisor, it was looking at each syscall, enter and exit, and all worked well. Let's assume that we figure out how to deal with this problem of enters and exits. But at some point, your process could die simply, right? Like, it went gone because maybe there is 6seg, or maybe there was OM kill, or maybe this, or maybe you forgot to put something inside the policy and your sandbox C could kill your supervisor. And right now your process is gone, and when the Ptrace supervisor is gone, nobody is looking at your syscalls. You are free to do whatever you want. So a couple of people active on the LKML and also interested about Linux security started adding those features. And I believe that when you take the kind of newest kernel right now, you can with great confidence implement properly working sandbox with Ptrace. A Ptrace implementation of a sandbox that I wouldn't find any obvious bugs in the implementation, right? But it's not to mean that it's safe technology by itself. It still has this baggage of being debugging interface and being implemented for something else than
okay, so one question about it. What about multithreading?
Oh yeah. So yeah. So before I told you about those syscall entry events, you can take a look at the registers, and when you have open syscall, one of the registers, the first one actually, will point you to a userland memory which contains the path to the file that you want to open. It works all well if you are single-threaded, because when you are in this moment when you invoke syscall, your process is stopped and you cannot do anything, right? It's safe to examine your contents of your memory and all is dandy, everything is fine. But if you are multi-threaded, the other threads are running, right? In Linux, you all know that threads are processes basically, so there's nothing like stopping the whole process or anything like that. Other threads are running. So you have this very typical time of check, time of use problem, where your supervisor is checking the contents of userland memory and then say, fine, this is in my syscalls, go ahead, right? Open this file, ask the operating system to open it. At this moment, second thread is changing contents of the memory. And well, you are opening file which is not in the whitelist, security violation, bypass of the sandbox. So people were so vested into using Ptrace to sandbox your applications that they were started thinking about how to bypass this problem. And I can tell you there are crazy solutions to do that. For example, you can allocate read-only memory inside your process and then create sandbox policy which will never allow it to change from read-only to read-write, or basically write, execute, whatever. And then what you can do is basically you wait for a process to call open syscall, you read the contents of the path. Now you're using Ptrace interface, which bypasses memory protection checks. You use this Ptrace interface to write it into this process read-only memory. You change the contents of the register to your read-only memory and you allow the process to run. And if you don't allow the process or other threads to change the permission bits of this memory, this is conceptually safe. But it became so crazy-ish that people said, okay, that's probably the end of it. We shouldn't go any further. Though you can find solution based on this idea. I think one is called Mbox, if I'm not mistaken, which is implementing exactly that. But yeah, it became crazy at this point and kind of fragile. So we were looking for other mechanisms.
Okay, so let's quickly go through other mechanisms. I see there are like, if I'm counting correctly, 73 million questions. So let's go quickly through other mechanisms.
Right. Sure.
And then let's go to questions. Perfect. What's Seccomp?
Seccomp. There was a Seccomp which was implemented in 2000 something in the Linux kernel. It was mechanism which allowed only for 4 syscalls, which was read, write, sig, return, and exit. It was Seccomp version 1. And people were thinking that, okay, now maybe I can lend my CPU time to somebody else, maybe for Bitcoin mining, not that Bitcoin knows at this point, but actually it's a good idea, right? So you tell people like, give me any binary you want. It can invoke only those 4 syscalls. If you restrict your process to those 4 syscalls, I will run it for you, I will sell you my CPU time. And that was Seccomp version 1. And people were thinking, yeah, that will be foundation for sandboxing Linux, but it turned out it's completely impossible to do anything reasonable with those 4 syscalls. At some point, you will have to have access to memory, and you need maybe like 30 syscalls to do anything reasonable. So it didn't work. And then Will Drury from the Chrome OS operating systems came and said, okay, let's invent Seccomp version 2, which is based on BPF, on Berkeley Packet Filter virtual machine. This virtual machine is actually ideal to do that, because the only thing it can do is basically check the contents of some structure against some constant values or other values in other registers. And that's what you need for syscall checking. You basically, when you open a file and you want to make sure it can be opened in read-only mode, then you expect that your register, which is responsible for the mode of opening file, contains value, I believe, 0 at this point. Easily checkable, right? And you can return value from this virtual machine. Allowed, disallowed, to be killed, invoked, signal, something like that. So after a couple of months of back and forth on LKML, we'll made it into the Linux kernel. And from now on, it became de facto standard for Linux sandboxing. For example, the first user was obviously Chrome and Chrome OS. And later it was added to other big packages. For example, currently OpenSSH is using it.
Okay, so to sum up Seccomp BPF, you basically create a policy which is a script, like a bytecode, for which checks the syscalls, right? And based on, if you issue a syscall, then kernel goes through this policy and starts executing the virtual machine of BPF, as we mentioned before, and checks if the syscall can either be executed, right, or cannot be executed. Or I guess there's also a fallback to another process to the side, right?
Yeah, it's a little bit more complex. There are things like you can still use Ptrace supervisor to do interesting things and so on. One drawback of Seccomp BPF, there are a couple of drawbacks, but one interesting thing about it is that syscall table is different between machines. So your bytecode that you upload to the kernel is different between our machine and x86 machine, because syscalls differ, arguments to syscall differ. So what you should do when you are writing a policy, you need to write it with these expectations in your mind, right? Like this syscall number is different between machines, or that some syscall exists on some machines and not some machines. So you need to be kind of careful about that, and you cannot just create bytecode once on some x86 and transfer it to in form of some byte array to some other machine.
Yeah, I guess a canonical example of Seccomp BPF bypass on CTFs is basically when the architecture is not checked and somebody has like a 32-bit process with a 32-bit policy, but you can actually switch on x86 32-bit to 64-bit mode, and suddenly the policy lists different syscalls because the numbers of the syscalls change, right? And
exactly. So x86 32-bit is this original Linux syscall table. And I believe Linus was thinking from the very beginning that will be the only architecture that will run it. So it included some syscalls which are unheard of on other architectures, like modify LDT, modify local descriptor table. Do you know that? So when they started implementing Linux for other architectures, they thought, what the hell, right? We're having those syscalls which doesn't make any sense on my architecture. Let's clean up this mess. So they created different syscall tables, and there's one kind of standard and portable syscall tables that x86 64 is also using. So that's why syscall numbers differ, and you need to be mindful about that.
Yeah, that's true. Yeah, so I think there was a chat on the channel about this a couple of days ago, but Linus actually created Linux on 386, so that's probably the reason why x86 32-bit is the platform where the basic, well, everything grew up, right, in terms of syscalls. Cool. So, okay, so we have Seccomp BPF to basically handle the syscalls. Now we have namespaces. What are the namespaces, which are not C++ namespaces, these are Linux namespaces?
So, can we back for a moment to Seccomp BPF?
Yeah, okay, let's
because,
go back.
Just to close this topic, at least for now, so Seccomp BPF can only check the contents of registers. And as I told you, you cannot check when you invoke OpenSyscall, for example. It's representative of many syscalls which are taking pointers to user memory. You cannot check this memory with the Seccomp, right? So now you have a tough choice. Either you write your Seccomp BPF policy, which, for example, allows only read-only files, what you can do on Seccomp BPF level, or you need to find out, another mechanism to implement this whitelist of files that you want it to open. It's files, network connections, some other interesting things which are taking pointers to the user space. So as paradoxical as it is, many sandboxes which are using Seccomp BPF are also using Ptrace on the top of that. Because when you open this OpenSyscall, you need to have another process which is basically taking a look at the memory and again comparing it against whitelist of files. It's way better than using regular Ptrace to sandbox processes in this way that when you use it with Seccomp and the Ptrace process dies, the syscall is no longer allowed, it's disallowed, right? And in this regard, this is better. But yeah, it was kind of paradoxical for some time where like people were using Ptrace along Seccomp BPF, right? This old interface that should have died many years ago for security.
Okay. So now come in namespaces, I guess.
Yes, so namespaces, I actually don't know how namespaces exactly started in Linux kernel. It was some part of virtualization efforts inside Linux kernel related to OpenVZ and similar technologies. It started appearing around 2008, 2009, I believe. And the first use for security, I believe it was used inside Chrome. browser for Linux, when it was used to cut off the process from the next access to the networking. So namespaces at the beginning required root access. In order to use this unshare and clone syscalls with special flags, you had to be root. That's why if you are Linux users and have Chrome, you can find in opt/Chrome, you can find something called suid sandbox. It was the first name of Sandbox, and it required the set with ID root privileges to invoke those namespaces to cut off access from networking and then access to other processes. So at some point, I believe around 2012, I don't remember it exactly now, they allowed to use those flags and namespaces without access to root. It's called clone new user namespaces, and from now on the sandboxes based on namespaces exploded. There are so many things based on it. So not only sandboxes but also containers like Docker. So you have Docker, you have NsJail, you have some other things which are there in this space. So namespaces, there are a couple of namespaces, and they all mean to put your process in separate view of the resources which are there on the operating systems. So one resource is, for example, your file system. So when you put a process inside such mount names, so-called mount namespace, you can mount only your files and nothing else. And it goes towards what we really want to, which is like to have inside the sandbox only files that should be accessed. And you can do that with mount namespace. With network namespacing, you can cut off access to the networking. So you will see no interfaces. You can obviously invoke syscalls which are related to networking, like connect and socket and so on. But because you don't have access to the routing table or interfaces, you won't be able to connect anywhere, only to your loopback. So that's one nice treat. There are some other namespaces which are less useful for sandboxing, like changing your host name, for example. But it all allowed to create really nice sandboxes, especially in conjunction with Seccomp BPF.
So there's also, you mentioned, I think PID namespace, right?
Yes.
So you cannot use the trick which you mentioned in chroot, right?
Exactly. So the Seccomp BPF, it, for example, allows you to, you can take a look at the registers of a process during a syscall. And there are many syscalls which need to be allowed, though they are kind of inherently insecure. For example, you have kill syscall. And kill syscall allows you under Unix systems to send signal to arbitrary process.
What's the story behind that name? How can you name like something which should be called send signal kill?
I believe Ken Thompson works in your company, you can ask.
I guess.
So yeah. So when you introduce PID namespaces, process namespaces, your process is put into separate process ID namespace. And you can see only those processes which are in those namespaces, which initially it's only you. And if you use any syscall, which is taking as argument process ID, this process ID must be also inside namespace. So from that point on, it became possible to allow, for example, for a kill syscall totally unconstrained without any checks, right? Because that's the operating system which guaranteed that whatever you will do with this kill syscall, you will only kill yourself or other processes which are presumably also sandbox, which wasn't a big problem.
Okay, perfect. So I guess NsJail uses both BPF and namespaces, right?
Yes, because these are ideal things. Basically, these are those two things which allow you to implement well-working sandbox under Linux. Seccomp BPF alone is not enough, and namespaces are not enough. So I told you why Seccomp BPF is not enough, right? Seccomp BPF can only check the contents of registers, not userland memory and so on. Namespaces basically shrink resources to amount for which Seccomp BPF doesn't need to check those syscalls anymore, right? So you can allow for wide open because everything you can open is what is your namespace, and presumably you put it on purpose and not by mistake. But also allowing only namespaces is not okay. I told you about Docker and kernel attack surface, but yeah, namespaces don't shrink kernel attack surface. and you have a couple of root privilege ring 0 escalation bugs inside Linux kernel, and you need to have a mechanism to shrink this attack surface to limit syscalls to only those syscalls which are used by your sandbox payload.
Okay, perfect. So I have 3 other technologies listed on my list of sandbox, which is by the way taken from Robert's presentation. So let's go quickly through them. First one is my favorite, which is native client, which I totally like the technology. I read the paper when it came out and it was quite amazing. It's also somewhat related to Chrome, since Chrome implemented native client. So what's native client?
So this is as awesome technology as it's not used anywhere, I believe, these days. So native client, the predecessor of native client, I think it was called X32. There was research paper about how to constrain Intel executable code using segmentation and clever tricks like not allowing calls and so on. And at some point people said, okay, let's turn this idea into a real project. It became native client. Native client was really complex, but it was really, really nice. When you look at it, like, the research was legitimate, and those protections were also really, really nice.
It's beautiful technology, yes, really.
But it created it became kind of problematic to write illegitimate software to that, because it allowed you to only use the CPU, your CPU time, as well as memory that you have already allocated. And for anything else, you had to ask a special trusted stub to do it for you. So aside from compiling your code with special compiler into Knuckle, you had to write those small stubs, which were trusted. So you were evaluating it from the position of the trusted base. So your untrusted process tried to allocate this memory. Do you allow for that, right? And then you had to write code for basically any syscall that was there. And aside from the initial excitement that it will be the first working x86 limiting technology, and it's occasionally used at some point, I believe, in Chrome, it didn't gain much traction right now. I'm not sure if it's still used in Chrome or not.
I think it's still enabled, and there's also the pinnacle later on. So
yes.
Native client was basically to give you a hint what it was, and I actually really recommend reading the white paper because it is really a beautiful piece of technology. It's basically you have a program in C or any other language, and the special compiler compiles it in a way that doesn't use, for example, jumps and other instructions, but a special kind of jumps, which are doing additional checks. And then when you run a native client application, the environment where you run it in actually does actually checks first before running your program. Do any and every instruction, is it correct with the knuckle specification? If there is like any instruction which is not correct, then the application will not run. If there is a jump which doesn't jump to a 32-byte boundary because that's what the knuckle specification said, then the application will not run. If there is any code which is self-modifying, then the application will not run. And there are a set of constraints which basically made the code safe to run, and with addition of some like CPU features like segments, which Robert mentioned, you could actually get code execution without any checks at that point, which cannot do anything malicious and cannot do because of the constraints, and actually can run at full native speed almost, apart from doing the syscall-like stub calls.
I have big sentiment for this technology. I think it's part of a history now. Do we have my presentation in this PDF? Because yeah, I included one slide about it, and I think it would be very informative if we can...
just scroll through it. Sorry, I'm going to do this.
Yes.
Maybe...
Can we look for knuckle? Just...
Yeah. Here we go.
Yeah, that's two slides. The first slide is basically how it kind of looks like. So you can... Yeah, you can...
There, scroll.
So this is basically how those jumps looks like in reds, right? You can only jump into very specific pieces of code. All jumps are verified. Like all the code is basically verified for a wide list of its x86 instructions which are allowed. So yeah, awesome piece of technology.
Yeah, it's like native client was really amazing, and if you're into security, totally do read the white paper. It's a shame it wasn't used in the end, but yeah. So going back to the next what's on my list is virtualization. Like for example, why are we bothering with sandboxes if we can use KVM or Zen or like VirtualBox or I don't know, VMware to just virtualize the whole file system and done?
Sure. I wasn't also looking very much into Xen. I believe I might be totally wrong. I admit that I haven't looked into implementation of it, but I believe those first versions of Xen were basically operating systems working with kinda aside the main operating system. Like basically it was the kinda the same process, right? And I think it changed over time, and now it's a little bit better. But early versions had bugs, and they were found pretty frequently. The funny thing about KVM and using it as a form of sandboxing. So first of all, not every CPU was supporting that. So when first version of sandboxes were implemented, KVM wasn't there, or the interface wasn't stable. But now, yes, many people are trying to implement nice KVM based sandboxes for that. So first of all, it's not faster. For example, when you have Seccomp BPF, the BPF bytecode executing in the kernel is really fast, and it doesn't make KVM based solutions faster. Secondly, maybe we can also go to the slides.
Sorry, we had, yeah, okay, last slide here.
KVM, yeah, I think last ones earlier a little bit. Oh, here, yeah.
KVM, here we go.
So the thing is that KVM is no really better than running a process without syscalls conceptually, because the only thing process which is running under KVM can do is basically execute, use the computational resources of the machine, which is to say, to use the CPU, right, and the memory which is allocated to it. So if you want to do anything which is beyond the kernel which is running inside KVM, you need to ask your uber kernel to do it for you, right? If you want to write something in the console, the kernel which is running inside KVM will have to, through some special interface, ask the parent kernel or parent supervisor to actually put this character on the console. So the funny thing about KVM is it itself is not a perfect sandbox, because it's doing a lot of functionality which is totally outside KVM. It's basically, if you think about QEMU has a lot of code which is doing crazy things, which is totally on sandbox. It's doing networking, file system access, things like Plan 9 file system access, nothing network connections, and so on. So KVM is not sandbox per se, right?
So you're basically changing the kernel attack surface to a hypervisor attack surface.
Exactly. So yeah, you are looking right now at the slide. So it's not only this part that we are talking about, like emulation of devices and so on. It's in the green here. The funny thing is that over the years, people found a few bugs in implementation of virtualization of CPUs itself. So I found one bug.
The AMD bug.
Yes.
I think it's somewhere here in the presentation as
yes.
well.
Shameless plug, I was nominated for a Pony Award for that. So basically you executed regular process inside the guest, like no special privileges, you are virtualized, and you use something called PMU, which is Performance Monitoring Unit. It's a modern part of CPUs, which is responsible, for example, for counting instructions or such things. And it was transferred by KVM into the host kernel, which had to in fact instrument CPU to do that for you. And there was a bug inside AMD processor. When you enable this performance monitoring unit, I believe it was counting instructions that are executed inside the process. bad things happen in the host kernel, like native kernel, right? So what can happen, you for example could skip one instruction or skip 1 byte of the instruction, and really strange things started to happen. For example, you were having instructions which were not defined, like because you jumped into middle of instruction, or your stack pointer was changed by a couple of bytes, and then when you are doing read, the host kernel were doing read, you are returning into some crazy address, right? So so that's also the attack surface, but I admit it's probably a little bit bigger than when a process is running under Seccomp BPF or namespaces, because virtualization is using a lot of CPU resources.
Okay, so
but you can also try to tinker with CPU from regular sandboxes like Seccomp. So.
Okay, so I guess we have an attack surface in both approaches. That being said, Seccomp BPF might be faster for processes, and if you need something bigger, then you might want to go with XAML KVM. It's like different tool for different jobs. That's my take on it, at least.
You need to create other attack surface with KVM solutions in order to avoid attack surface in some other place, right? You need to still write hypervisor.
True. Okay, and the last one is just emulation, CPU emulation, like, you know, QEMU part of emulation or box emulation, which doesn't use the hypervisor technology. What do you think about it?
I was only looking at the number of bugs in those solutions. And when you look at the history of bugs in QEMU, VirtualBox, VMware or something like that, it's kind of staggering. There are bugs everywhere. In VGA emulator, Kostya Korczynski, a couple of years ago, he released a bug, I believe it was VMware, if I'm not mistaken, in which you were sending a specially crafted PDF to a printer server exposed by VMware, and there was a bug, right? So you basically crafted PDF, send it to your virtualized printer, and there was some buffer overflow or something like that. You pwned over the host machine. Honestly, I haven't been looking at the quality of the emulation itself. Do you know any history of like things in which improperly emulated code could lead?
I think actually Tavis has quite a lot of bugs. He had a presentation. It had a funny name, like there's a party in somewhere and you're invited. Anyway, there were bugs like, for example, where you had previous escalation bugs which could only happen in QEMU. So if you had your kernel running in QEMU, due to how QEMU misbehaves on some instructions or doing some stuff, you could do a escalation there. And I can look it up later, but basically, yeah, basically what you're saying is exactly true. Cool. So I guess we can get to the questions. I'll start with the questions which I have noted from before. So does it make sense to use NsJail in Docker? You mentioned that Docker is not a sandboxing solution, NsJail is. How about we use NsJail in Docker?
So actually it's possible to use it because I think Emlan, is he watching us? He provided a Docker build script inside NsJail, so you can use it.
So is it Emlan, or was it disconnected?
Oh, I'm really sorry if I'm like giving credit to the. We can check, but
yeah, I'm going to look, and you keep talking.
Yeah, you're right. Right, sorry guys. Yes, so somebody's said in those questions that somebody's considering using NsJail inside Docker for CTF challenges.
So that was disconnected.
Yes,
sorry. Yeah, here we go. Actually, I'm going to give you a link. Okay. Yeah, sorry, please go ahead.
So what typically happens inside Docker, you are putting the whole solution which is maybe serving multiple users. So you can put your CTF challenge inside Docker, and somebody asked that inside Docker you will have inetd, which will run separate instance of your challenge for each contestant. But the problem is that, okay, inetd can run this separate challenge for each contestant, but when this contestant gets remote code execution privileges on your machine, it will be able to tinker with other, solution processes which are running out there. So if you are the first one or one of the first ones, you can simply retain code execution on this machine and try to kill any other process which other contestants are trying to solve, right? So yeah, dosing
but
basically
it never happened on a CTF.
Not until the NsJail came. So that was one of the reasons that I created NsJail. We were organizing CTF in Poland during Confidence Conference, and I was thinking how to do that. Docker was really in early stages, so maybe not released yet. And I thought, okay, we need to have a challenge for each contestant, each running with its own separate sandbox. And that's the first operational mode of the sandbox that was there.
Okay, cool. So, so I guess there's also a follow-up question, how to do it securely. Please look at the container from Disconnected. Disconnected also plays CTF, so I guess he knows what he's doing. He's the captain of one of the Polish CTF teams, so yeah, and also a winner of some CTFs in Poland. So I kind of trust him on embedding properly NsJail in Docker.
Yeah, I admit that my Docker skills are non-existent, really.
Cool. Then we did already chat about Docker. Okay, so can you give an example of, like, if I would give you a console, can you show us how to run NsJail?
Right, let's do that.
Okay.
So
which one do you need? Here we go.
Yeah. So if you are reading Genvals or my Twitter, you probably noticed today a tweet in which I invite you to get a shell on one of the machines that we are running in here. So you can use netcat or telnet or something like that. Maybe I will repeat the link in here. It's basically stream nsjail.com at point 37339, right? Oops, yes. Oops.
I can check out Twitter quickly if you like. Sorry. For the port, maybe it's down though. No, here we go. Oh, it's one here. Yep. Oh, sorry. Here we go.
Yeah, so you can play it a little bit with it. It's secured. Is the size of the font okay for?
Yeah,
people?
it should be fine.
Okay.
It should be fine. We can move. Sorry, we can move the window row here so the camera doesn't. Okay, here we go.
So we can play a little with it, and basically that's the view of the system that you will have when you are kind of sandbox.
So this is Bash running inside NsJail.
Exactly. I will show you in a second how to invoke NsJail and what those secret incantations mean. But I thought that we can enjoy it for a couple of seconds, the view of the system from inside of such jail. Okay, let's do it again. So basically, when you type mount into it, you will basically see what you have inside of such jail. I was telling you about the mount namespaces. They allow to mount only files you really need inside. So for you need really for Bash is basically, you need, as a root file system, you basically need, there was some secret key that you taught me to use.
Yeah, G3.
Yes. Okay. So basically we have tmpfs, which is root of our file system. We have a couple of directories which we really need to run Bash, as well as those commands that you are typically typing inside your console, something like ifconfig and whatnot. A couple of demonstrations of files that you can put inside. They're kind of harmless, right? Used by some applications. And at the end, what you can see in here, you will have tmpfs in your tmp, and we are right now inside. Oops.
Just escape.
Just escape. Okay. And we are right now inside this TMP, which is also TMPFS, and you will have your own proc. Proc is needed for the PID namespace, for the process namespace.
Yeah, just escape. I think you touched G3 or something.
Okay.
G4.
What is interesting that your proc will only list processes that you will have inside your process namespace. So number one is your Bash. and then I did one command which probably got process ID number 2, and now I typed ls, which is process ID number 3. And basically you have obviously other processes on the system, but if you invoke syscalls through commands like kill or anything like that, you won't be able to touch them, right? The kernel operating system will basically try to translate your process ID into global process ID, and if you use some global process ID, it's not translatable into real process ID in the global namespace. The kill will return with something like no process found or something like that. But if we wanted to take a look how to invoke such bash, we can go in here. Is it okay? Okay.
Sorry, I'm going to move
sure.
to this because
Fine.
I do have some border. Yeah, this should be fine.
Yeah. So maybe just use cut.
Oh, that's easy.
That's easy.
So okay, walk us through this magical incantation.
Okay, so because Genvalens claimed that easy as a sarcasm, I can tell you that if you really wanted to run bash inside simple sandbox, you basically need only 2 parameters, which is basically your Chroot argument, which is not real Chroot, it's namespace Chroot, and basically address of command to execute, right? It will by default put it into separate bit namespace and so on and so on. I wanted to do a little bit more crazy example, so as to show you what NsJail can do. So those crazy incantations at the very beginning in here, yes. So they tell you that you will run it on TCP port because NsJail allows you to both sandbox applications which are coming through TCP in ADT mode, as well as local applications like daemons, like servers like Apache or OpenSSH or something like that. These are things like tuning the timeouts, so each session will be maximally some time, what port we are listening with, and this is interesting. This basically tells you what to put inside such mount namespace. So I told you previously that we should put only things that we really need. This is sort of a list of things that we really need inside Sandbox. If you don't care for a moment about what you put inside, you can basically use a command called Chroot, which will chroot some directory, only some directory. So you can have a copy of your root file system in some special directory, presumably with no secrets, no data to be leaked, and then you can use only this command, right? So in really simple use, we are skipping a lot of that. This is like creating temporary TMPFS directories and so on. This is how your user IDs are mapped. So basically it means how your internal view of user IDs, UIDs or GIDs, are viewed externally. So in here it's really simple mapping. When you are using this user ID of a number 999 whatever, it's also seen outside at 99999, and if you have root privileges, you can create any crazy mapping out there. Also a mapping in which you are internally root, which is you have user ID 0, but outside you are not root, which means that you can fool people or play with people or create CTF challenge or like fool yourself that you are root of the system without actually having access to the root privilege. So you probably remember this old exploit in which it was preloadable library, which was providing you the symbol for get a UID, which was returning 0. I think Seccomp was the first to to put it out there, and he said, yeah, compile this little library for me, preload it, and run user bin ID, and it showed, yeah, you are root, right? So this is kind of the same. It will return 0 in request for user ID. Other things you probably recognize, like environment variables, and these are interesting things which are telling which are telling you how much resources you can use on your system. So basically you are allowed only to use one CPU out of many. There's something called affinity in the modern Unix operating systems. How many connections per single IP are there? or how much memory your total pool of processes inside the sandbox should use, right? This is the Seccomp BPF policy that we talked about. We can take a look at it later, which limits what you can do. Currently, it only limits the syslog syscall, which disallows you to use dmask command. I can show you that in a second. This changes the host name of your jail. Obviously, some additional limits and one cryptic thing that I can show you later.
And
yes.
And at the end, this is what's actually going to be run, which is
yes,
this bash -i.
we are run. Yes, I for interactive. It actually shows you the prompt when it runs without on a socket instead of TTY.
Okay.
So very quickly to show you, for example, that we are currently having a command line which is called NsJail, but when we connect to the
I think we have a different console open if you're looking for it. That's
I think it's fine, right? But when you type a name in here, and actually this this string is provided to you by the operating system, it's not like anything inside userland. The kernel will tell you, yeah, you are running on some other box.
I'm actually surprised. I always thought it's like /etc/hostname and it's read from there, but okay, good to know.
Yeah, you can set it arbitrarily. Okay, we can maybe take a look at the second policy in here.
So could you show me that the dmask doesn't work,
sure.
Actually? Do we even have the comment in the jail too?
Yes. So we have dmask. Okay. Don't worry about the message which is out there. This is a message from the bash which is not running on the terminal but on the socket, so it's like getting a little bit crazy. But we can take a look at what happens when we actually invoke this command. Where is dmask? It's been. Yes. So as you can see, the dmask at some point is invoking syscall called syslog to get the dmask of the kernel debug messages. And at this point, the Seccomp BPF policy is telling the kernel, if any process invokes syslog, kill it. So the kernel is killing our process with 6s, the syscall is not allowed, and everything is fine.
So it's only calling the process, not the whole sandbox?
It's calling the process.
Sorry, killing.
Oh yeah, it's killing the process which caused the violation.
Okay.
Yes.
Fair enough.
Yes, yes, exactly. And let's take a look at the policy. So this is really simple policy. The language is called Kafel. It's part of NsJail. It was created by our intern Victor, who was interning at our company 1.5 years ago. And Victor was really well versed in those crazy technologies like Flex and Bison and so on. So he created really nice policy description language. The project is called Kafel. You can find it on GitHub under github.com/google/Kafel. And you can see what you can do. As you can see in here, our default policy is allow for every syscall, but kill for syslog. It basically means kill with the 6s signal, but also return 0 for get with and get effective with. You probably remember when I was talking about this prolo double library which was fooling you that you are root of the file system. You can do that in here, right? So as you can see, there is this hash at the beginning at the bash prompt, which means that you are probably root, right? You can take a look at it and type ID, and truly you are root, right? Even if the mapping says that user ID 9999 is mapped to real 9999, there should be no roots whatsoever in your path. And probably you can take a look at proc self status, and you will figure out that, yeah, your user ID is actually 9999, right? So Seccomp is not only security mechanism, but if you are creating maybe CTF challenges, maybe challenge for your friend, you can easily fool people into thinking they are roots when they are not, that the syscalls are executing when they are not. The possibilities are kind of endless in here.
So it's a trolling mechanism.
Yeah, it's a good trolling.
Yeah, trolling is a art. Perfect. That's actually amazing. Cool. So thank you for the demonstration. I guess we should go through the 1 million questions now. So let's grab one from the list. Okay, so okay, I'm going to just note it down. Sorry. Grzegorz asks, is it popular to use Sandbox for interpreted languages like Python, or is it most used for binary executable programs? That's a good question. What do you think?
I'm maybe underestimating the question. I mean, for me, whatever can be a process inside Linux can be sandboxed. So Python is obviously regular Linux process written in C these days?
Yes, it's in C.
So you can obviously use it. There's no limitations of the languages that you write your processes in, as long as they are processes, right? So you can run the whole Python interpreter inside the sandbox. But maybe I'm trying to read too much into question. Maybe the meaning was like whether the Python can be directly interpreted by sandbox.
So I guess the question would be, does it make sense? I have like a huge script in Python. Does it make sense to sandbox it?
Okay, so if it's there are two answers to that. So when you are executing a script or any binary which is coming from kind of untrusted source, it's probably a good idea to sandbox it. It's probably not a very good idea to execute totally arbitrary binary you found on the internet, but maybe somebody provided some proof of concept for some interesting idea on GitHub. This person is reasonably well known, but okay, maybe that person went rogue and like put some kind of exploit inside your script or program or something like that. And then I'm running usually those semi-trusted binaries inside NsJail, so that's a good idea. The second idea is running legitimate processes on sensitive systems. What I mean by that is that sometimes you need to run third-party binaries on your system. You know, there are specific binaries which are checking, like in big server setups, there are binaries which are checking status of your BIOS or something like that, which are coming from big vendors like Intel, AMD, Asus or something like that. And you can reasonably trust them that they are not going to steal your data and transfer it overseas, but who knows?
Yeah, if we don't trust Intel, we have bigger problems.
Exactly. But the additional process that you don't know whether somebody didn't hacked into those companies and maybe put additional backdoor in there, right? So that's esoteric concern, but kind of valid. The second is that maybe there are kind of honest mistakes in such programs. Honest as in, it's kind of popular these days that people are putting this telemetry things inside the binaries, right? If you have big company, a lot of code, big code base, and maybe there is this telemetry directory somewhere in there, and somebody by mistake will link it in with your binary, right? And every 10 seconds some TCP connection pops out and sends some data about your system to, you know, some big headquarter. It doesn't need to be malicious, right? It could be simple telemetry, like if your process crashes, maybe it sends a core of your binary so some people can actually take a look what happened and fix the problem. But it's not good if you run it in sensitive environment. So running inside even in something which is not really a sandbox, but even cuts off network connection is a good idea. So NsJail can help you with that.
Okay, so there's another question, which is something I wanted to touch on as well. What about, NsJail probably uses its own network namespace as well, right?
Yes.
How do you route connections between, like, for example, can you allow some IPs to be connected from inside the jail, or can you disallow IPs to be connected from inside the jail?
So the network part of the NsJail is kind of underdeveloped. We have only some rudimentary operational modes about networking. We can either totally cut off the connection or clone the interface, like presumably your Ethernet interface inside your namespace. Assign IP to it and let your process run. It's obviously better that if you were on the host networking stack, because you cannot connect to the loopback interface or something like that, but still not perfect. There are ideas about doing what the question is about. For example, it's possible to implement something called slurp code from QEMU. It basically would expose tunnel interface inside such jail, and then a process which is running outside the jail but still having access to the file descriptor representing tunnel interface can basically get the packets from the tunnel interface, interpret them, network address translate them, and relate to the host networking stack. So I can only tell you that if you are interested in sandboxing, networking, those low-level things, and you have a little bit of time to spare or need to have such functionality, then let me know, because it's kind of interesting area to work on.
Okay, thank you. So the next question would be, can you make access to some files read-only? And if so, how to do it? Like, for example, you showed in the config that you are mounting certain files,
yes,
right? But you mounted them all as read-write, I guess.
Actually, read-only everything.
Oh, okay.
Maybe we can actually show second config. I promised the last one today.
No, totally. Let me switch just the view.
Yes, that was the other,
go.
the other console.
Sorry, let me find the other console then.
Or maybe we can relog as well.
No, that's fine. Here we go.
Yes. So in here we have sandboxed Apache. Apache typically comes without any kind of sandbox, and we have it in here. So we have our NsJail, and by the way, can we switch to the browser maybe for a second?
Of course. So here we go.
Yes.
Here's the browser.
So this Apache is running on the host ns-brief nsjail.com 8080. It's unboxing Apache. This page is just to show you that Apache can be made to work inside Sandbox. So it works. It says it works.
And it's actually faster than my blog.
And I can quickly show you what's the configuration for such. Oops, I think we are on the wrong console.
Yep, just on top then.
Yeah, okay.
Here we go.
So NsJail has two configuration modes. One, you can configure it through command lines, and it's very useful if you want to do something very quickly, proof of concept, or not very complex setups. But there is also protobuf based configuration files.
Yeah, it's already obvious which company you are working for.
Wow. And that's the configuration file, and presumably if you are maybe working in a company which is having big set of servers or running some really important server, then you might maybe want to put it in some configuration files. Maybe you can check it into a repo or share it with other people instead of this clunky command line console. So so I was trying to make it so everybody who is reading that kind of understands what's going on. So we are limiting Apache in here a little bit. We are setting some limit. I believe your console doesn't display underscores.
Yeah, there are a lot of underscores around, but
yes,
I don't know why my console doesn't like them.
So we are limiting the size of the virtual space of the Apache, which presumably limits memory use. It's not so good, but we're using other mechanisms to do that correctly. We are limiting the pool of file descriptors that a process can open. We are not limiting the CPU time because we want presumably Apache to run forever. Number of files and so on. We are also disabling limits. A couple of environment variables which are needed by scripts. We are also not entering network namespace. So this example actually runs Apache in the native stack, network stack of your host. So it has access to the local loopback and to the main loopback and to the main interface.
So is it to all interfaces, all network interfaces?
Yes, that are visible from the main system,
okay.
Yes. But obviously if you are doing more complex setup, you should probably clone interface, which is to say you will require another IP for that. So it's analog to the FreeBSD jail when you also need separate IP. So these are those mappings of user IDs, local versus global. Somebody was asking whether things can be mounted read-only or read-write. So by default, all files are mounted read-only. That's the default setting. If you want, you can set a flag in here, which is called isRW. Yes, we have it in here. So in here, right? So in run Apache, Apache puts its process ID, this convention of Unix daemons putting PID files somewhere. So we need to have it read-write. It's TMPFS, so it's a scratch directory, but it's also read-write true, right? So default settings, I was trying to make it in a way that default settings are kind of safe, and only if you really need to do something less safe, then you need to explicitly state it. So as you can see, Apache doesn't really need much. So this is interesting. It actually fakes the contents of your etc passwd. The reason for that maybe we don't want to expose to potential attackers contents of your etc passwd. The only thing that Apache Web Server requires is mapping of its www data into some ID. In our case, 1. It can be any fake ID because we are inside namespace, so we can use any IDs we want. And in fact, we are mapping in here this inside ID 1 into real www data. We need to do that because Apache Web Server needs to have access to var www.htdocs, which contains, its original index HTML. So if I didn't overwhelm you yet, that's basically all the files that I needed. So we need proc in here, we need some libraries for Apache process to run. We mount its data directory. So there you have this example index.html. Some additional files that are needed. And in here you have example policy for Apache. So this is beta example of a policy, because the policy should be based on whitelist, not blacklist. But it's an example policy. I guess I didn't have time to create a good policy for Apache. But if you want to use NsJail, I encourage you to create a really good one, which will have default action kill and only allowed syscalls allowed. And the last entry in here, it's also kind of important. So we are running our Apache, but we need to run it with the foreground argument. The reason for that is that most of the daemons in the Unix world, they demonize themselves, which is to say they fork and the parent exits and the child will run, right? And NsJail will treat this such behavior as the main process exited and there is no more namespace. So we need to convince Apache and any other daemon like bind or anything like that, don't demonize, just run as a main process.
Okay, perfect, thank you. So, okay, let's get to the next question then. Okay, we already mentioned about singularity. We mentioned about BPF and eBPF. About the question with JS VM, it was about about a new operating system. If a new operating system would be created with JS VM, I guess we talked about it.
There is this law which is saying that any technology will be ever implemented in any programming language or something like that. So people are implementing Linux emulators inside JS.
Okay. Zeza writes, I recently tried the first Linux patch and I have read some chapter of Linux device driver, but I think it's outdated. Any recommendation on book or blog for learning about Linux kernel? That's actually a good question.
I also never ever read any book about the Linux kernel. How I personally learned about Linux internals is that I was looking for bugs. I was looking for bugs in the network subsystem, implementation of sockets and so on. And if you are looking for bugs, you need to read through the kernel and understand it. So maybe that's a good idea, look for bugs.
Yeah. Actually try to understand and try to make notes on what you're reverse engineering basically of the kernel. I don't also know about any good book. There were books like, for example, I had one book about, which was actually borrowed, about Linux 2.6 kernel, but is like 4 dot something right now, so that book is kind of outdated. Yeah, I'm not sure. I mean, the kernel changes a lot, so I'm not sure if there's any up-to-date book. That being said, just type Linux kernel in Amazon, maybe you will find something.
Also, if you can actually read Polish, I believe at the Warsaw University there is a course called Linux System Programming, something like that, and they're having amazingly good materials about how Linux kernel works. At least those basic ideas about what happens when you actually fork a process, right? What kind of memory copying happens and what structures are created and so on, for Polish readers.
Okay. Hi, don't know if it was already asked, but what about differences between, I guess, NsJail and Firejail? Do you know Firejail?
Yes, I was chatting on Twitter briefly with authors of Firejail. So Firejail is a little bit later invention than NsJail. NsJail was initially meant to be sandbox for more server-style applications like daemons and CTF challenges. Firejail was aiming desktop applications. So they're having, the implementation is kind of good. I skimmed through it and it looks decent. They're having, in my opinion, a little bit less expressive Seccomp BPF configuration language. So it's my personal opinion, but it's not really so nice a scaffold. But to the advantage of Firejail, they are aiming desktop applications, which means they tackle the problem of sandboxing Xorg applications. Because as you probably imagine, Xorgs wasn't written with security in mind of the same privilege level applications. So if you can display anything on Xorg server, you can also do things like emulate keyboard and hijack keys, and so you can basically open a sandbox terminal and type whatever you want in there. So Firejail is trying to tackle that. They're using, I believe, Python implementation of Xorg filter called Xpra.
Okay, perfect. So next question is, can we limit the amount of space inside NsJail, like a disk space? Can we tell it that, hey, like this mount can use only this much space?
Yeah, 3 ways. One, you can use limited device size. So you can create a partition or something, but it's a least useful thing. The second thing, you can use good old quotas of the kernel. And the third solution is to use file systems which are limited in size. So when we are creating, for example, CTF solutions, which are mounting each real directory, which maps to some block devices read-only, and the only read-write thing that we expose is TMPFS. And TMPFS is limited in size. It's a parameter for mount. So the best idea is to not allow to write to real file system, expose some limited inside TMPFS. Otherwise use quotas.
Okay, perfect. So next question, how do you pass safely a secret to an application inside NsJail? So you have, I don't know, a password, for example, for a database which the application needs, and how do you pass it to the application so that it's harder to get for the attacker, like later on?
So this might be requesting of sandboxers conceptually something different that they were designed to do. If you pass a secret, there is basically no way to unsecret it, right? I mean, you can maybe close a file or do something like that, but you should never count that the secret is not left somewhere in the cache of something or in the process memory, yeah, something like that. So, but if you were really pressed to do that, there is this idea of passing file descriptors.
What do you need?
I believe it's inside this bash. So this actually console that we see in here.
Let's do, and here.
Yes.
Sorry, this one or the other one?
Yes, this one.
Okay, here we go.
So we are having our command, which is doing the following thing. Oops. Here. Okay. So what we are doing, this secret incantation is basically making open a file called root file leaking whatever under file descriptor 1023. This is a bash command. It's not an NsJail thing, right? It's not part of the command in here. This will be interpreted by shell. And then you can pass this file descriptor under a specific name. So you can say any open file descriptor under this name, let it inside the sandbox. So we are having this root file leaking in. So we can do cat root. We are right now at the host file system. It's on sandbox, but we can right now connect. We are right now in the sandbox. We can go to the process ID 1 file descriptors in prog, and you can see that you have actually this file descriptor opened. It was passed to inside the sandbox. It's only a name. It's a destination of the symlink. This file doesn't really exist inside the sandbox. But if you simply try to read from this file descriptor, for example, this way, you will see that. So it's possible in this way, but I would really caution you about putting too many guarantees on this behavior. Right now, it could be somewhere in the, maybe not cat memory, but if you are doing something more complex and you are processing this secret, it's,
Okay.
guarantees are limited.
So you can do the same with, for example, Unix sockets, I guess.
Yes, you can pass Unix sockets and then have some broker process outside.
Yeah, okay.
To give you some interesting
Perfect.
resources.
Thank you. Next question. Hardware question. Is cooling of CPU and GPU controlled by the driver in the operating system or by BIOS/UEFI or some other thing on the motherboard? Yes, yes, and yes. And apart from that, also some, like for example, I have a case, like a computer case, which actually has a device on some microcontroller where all the fans are connected, and these are system fans, of course, but also CPU fans. And I can switch, like push a button on the CPU case and control it with some buttons on the case. So yeah, I guess there are different ways to control it, and I actually honestly don't know, maybe Robert, you know, about what is the exact interface into these, like the speed of a fan, for example. It might be some, I don't know, SM bus or something.
Yes,
on the motherboard.
that's SM bus.
That's
I mean, it's not that I know PC architecture, but in Linux you are using modules and you are providing specific SM bus addresses or something like that. That's all I know.
Yeah, so SM bus is basically one of the buses on the motherboard, and for example, if your RAM has RGB lightning, which is, you know, the thing you need in your RAM, then you use also SM bus to actually control the color of the RGB.
And I can tell you, we have really nice LED lightning in here.
Yeah, but these are only blue. In that one, there's actually full RGB. Okay, does NsJail have any advantage over well-configured SE Linux? SE Linux is something we didn't mention today, or other Airbag Mac implementations.
So those implementations typically don't limit individual syscalls. So they limit access to certain resources like files or groups of syscalls. So I told you that there are a couple of kernel exploits per year, kind of reliable exploits. And if you create an NsJail with really nice whitelist of syscalls that you want really to allow, you have big chance that the crazy syscall which is used in kernel exploit is not allowed, so you are kind of safe. With SE Linux, I don't think it's the case. Last time I looked at the SE Linux was a couple of years ago, and it was limiting access to certain functionalities, not syscall. So I believe syscall whitelistic approach is better in here for this reason.
Okay. Would a custom kernel driver be faster than Ptrace for sandboxing? I guess kind of we answered that question with Seccomp BPF, because Seccomp BPF is actually a part of the kernel, so it can be considered a driver which is actually embedded into the kernel, and it's faster than Ptrace.
Yes, there is another piece of the Linux kernel which can monitor at least syscalls, and maybe with some small changes it can block the syscalls. This is called perf monitoring, interface. So there are a couple of bits of Linux kernel code which are seeing those events and can be at least modified to do that if you really want.
Okay, can NsJail support via Seccomp, I guess Seccomp BPF, a mechanism like pledge on OpenBSD to forbid allow syscalls only after a point of execution? So we have a program and the program says, now I want to be super secure and untrusted actually. Can NsJail support that?
No, no, you need to sandbox the process before it happens. Though Seccomp BPF itself, as in if you really wanted to use Seccomp BPF and namespaces can do that. If you want to manually set up the sandboxing or use one of the libraries, I think the Boxit is the library from which allows you to do that if you want higher level API. But the idea is that maybe at some point we will create NsJail as a library, right? So NsJail command will be only thin wrapper setting some structures, and then maybe you can use the library to do that in some really nice high-level way.
Okay, perfect. Is it possible to implement something like NsJail for Windows? I know you're a Windows fan.
Yeah, I can talk about it for hours. So what do you think?
Okay, so no, basically Windows, though maybe. I was going to say no because Windows doesn't have namespacing capabilities. That being said, I think there were some attempts to bring Docker to the newest versions of Windows 10, so they probably added something, but I have no idea how it works. That being said, in Windows, sandboxing generally doesn't work on syscall filtering levels. That being said, for example, the Win32k syscalls can be denied by some mechanisms introduced in Windows 8, and like for example, browser sandbox use them. That being said, the sandboxing in Windows works a little different, and if you want to, for example, filter syscalls, which is the thing which you would like to do, like in some of my previous company, I created a sandbox for Windows on that level. You actually do have to use some hacks to do it. Otherwise, there are some Windows provided mechanisms to do filtering on the file system level, registry level, and so on. But if you want to filter syscalls, then that's always hackish a little in Windows, and there is no mechanism to do it. So it would have to be, NsJail cannot be ported as is to Windows. It would have to be, would have to be out of changes.
By the way, is I understand there is Windows Linux subsystem in newer. So I was trying to compile HONGFAS and it actually runs in POSIX mode. But Windows Linux subsystem doesn't implement more complex syscall variants. For example, the clone syscall, which is used to create new process, only supports kind of basic flags. For example, it doesn't support like creating new namespaces and so on. But they are working a lot on that, and maybe at some point you can use Seccomp BPF inside Linux.
So NsJail doesn't work on the subsystem.
I haven't checked that, but I doubt the functionality is kind of.
No.
I would say it's not a priority. Well, maybe with Docker.
Maybe with Docker. That's a good question. It's worth checking. Okay, why are there so many bugs in commercial software?
I was talking a lot today. What do you think?
Okay, what do I think? Perfect. Because software is hard to write and languages don't make it, and libraries don't make it easy to write secure software, and this is both true for open source software and commercial software. There is no difference in security level, and that's a myth, basically.
So I would add a little bit to that. So I would mostly agree with what you are saying about software before maybe 4 or 5 years. I wonder if like those popular efforts of fuzzing changed a little bit the landscape. So, you know, the fuzzing became really big like a couple of years ago with the introduction, especially AFL, also other fuzzers, and people started fuzzing things like crazy. And people who maybe didn't think of themselves as security researchers, like capable of looking code, looking for bugs, now can simply compile a program, add really small instrumentation, run it under some fuzzer, and then bam, there is a bug, right? And they report it, and people are fixing those bugs mostly. So I wonder if it actually changed something that, you know, you reported your team many bugs in FFmpeg. I wonder what other producers of decoders, whether they're also fuzzing or not yet, because the...
So, especially like due to OSS fuzz, this landscape is indeed changing, as you say, but we have a lot of legacy code to test, and fuzzers, you know, well, fuzzers can only be so good. Basically find low-hanging fruits, right? And they will probably, well, current fuzzers will not be able to find some weird states, especially really complex states which are required to trigger some security bugs, and therefore, yeah, we will still have a backlog of bugs basically due to using old technology, like C and C++.
Maybe it's a good question to our viewers. Maybe somebody works in a big company or knows of a big company which is actually doing internally fuzzing on their closed source software. It would be interesting to hear.
Yeah, I know of a couple actually, but I'm not sure how public it is. So. Okay. Okay, anything on Windows sandboxes? I guess I kind of touched on it. My recommendation, if you're interested in Windows sandboxes, do read the white papers on Chrome sandbox, because they discuss a lot of sandboxing techniques on Windows. Because, well, Chrome was basically one of the first applications which had proper sandboxing. But that's one area of sandboxing, and there's also the other, like there are like applications like Sandbox C or like a couple of others which have a different approach to sandboxing, but they also use like kernel drivers and other stuff. So it's a long chat and we are running out of time, so let's not go into that, but maybe adding Windows sandboxes to some other stream topic would be a good idea. Can you run multiple NsJails within NsJail? Or can you secure Docker with NsJail? Like, can you run Docker inside NsJail?
Nice exception.
Yeah.
So as for running Docker inside NsJail, yes, you can do that. Long story short, if you enable read-writable proc, yes, you can run NsJail inside NsJail. As for Docker, I think so. In Docker inside NsJail, NsJail can set up a sandbox so it really resembles the original systems without Seccomp BPF filters. There are some limits imposed by the kernel, but with read-writable proc you can bypass them, I think. It should be possible.
Is it correct to assume that NsJail works like a syscall proxy?
No, it's not a syscall proxy. A knuckle is syscall proxy.
Yeah.
So you have a code which actually on one side it receives the syscall and like required functionality and really invokes the syscall in the operating system. What NsJail does is uploads the bytecode inside the kernel, and when the syscall happens, the kernel will run the bytecode to figure out whether the syscall should be allowed or not. So not a proxy in the typical sense.
Yeah, it's I guess more like filtering, like imagine a firewall-ish, but also Plasma namespaces, which is a totally different concept.
What if I can like elaborate in 15 seconds on proxies? So I believe early Chrome sandbox design were using something called proxy. It was called brokering, resource brokering. It's an interesting concept inside sandboxing. If you can impose really strict sandbox, for example, Seccomp version 1, which allows only those 4 syscalls, you still have access to read-write on some socket. And you can, for example, invoke some protocol, which is like, hey, trusted process, which you are on sandbox, can you give me contents of this file? And this trusted process, which is trusted, presumably cannot be touched by attacker, can make a decision. Yeah, okay, I can open this file for you and give you the contents. So that's called resource brokering in the Linux sandboxing world. Yeah,
and it was actually pretty cool on how it was done on Windows, because they actually hooked APIs. So inside the sandbox process in Chrome, you would call the APIs like normal, and they would actually do the brokered proxy call to actually request the stuff. That was pretty cool. I liked it. I originally, when I was analyzing the code, I thought that was the sandboxing part, and yeah, but it wasn't. It was actually just proxying. It was pretty cool. Okay, so you cannot port NsJail to Windows. Can you port it to Mac OS X or OS X, however you call it?
The truth to be told, I haven't tried to port to run NsJail under WSL, and if somebody wants, go ahead, maybe 1% chance.
And Apple OS X?
No, Apple uses different sandboxing mechanism. I'm not really into macOS, but I believe it's called seatbelt, and that's what I believe Chrome is using on macOS. It's different. It's different concepts.
Okay, so Brodato NsJail suggests using, if NsJail would work on Windows Linux subsystem, then use NsJail and then wine and then the application, and that's a proper sandboxing solution for Windows. Thank you. This is a great idea.
Yeah, it should
I
be
love it.
contests. Inception, how many levels you can make.
Okay, I have noted a couple of more questions, and these are the last ones. What are the limits or features of NsJail which you would recommend to do standard web application sandboxing scenario?
What are the features? So I will revert the question a little bit. So by default, NsJail doesn't give access to any resources. So run NsJail, figure out what resources are needed, and only allow them and nothing else. Right? Don't run it with like everything enabled and try to shrink it. Just run your application. Your application screams, "Sorry, I don't have access to this file." Give it access to this file, and work this way.
Okay, are there any side channel attack vectors that we need to look at particular when using NsJail? So, well, I guess like Spectre and Meltdown would work for all the sandboxing solutions basically beautifully because of the level. You can also do like CPU cache communication between NsJail and outside of NsJail because that's just how it works, and that's like CPU level that's way beneath the kernel and so on. But any, I don't know, other specific side channel attacks which come to your mind?
Not really different from regular operating system. Like, I wouldn't be, nobody tries, for example, to protect your sandbox process from maybe using some timing attacks to figure out what are process IDs on your main system. Maybe if you're using some syscalls, then the procedure of mapping ID, external ID to local ID is not time constant, and if you really want it, maybe you can read the CPU counter to figure out, okay, if I'm trying to kill process ID of this number, it takes this many cycles and this many cycles. Maybe you can figure out what's our process ID on the main system. But aside from that, I'm not sure.
Yeah.
Like, probably there is no big amount of what you can do on the regular operating system. You can probably do from NsJail in terms of site attacks.
Okay, so do you remember any vulnerabilities in NsJail?
Not really a security one. There was one in which, because I told you that NsJail basically sets up the environment and lets the process run inside. I don't remember any problems with setting up the environment, but there was one bug which was related to how many clients can connect from single IP to, for example, CTF challenge. So my comparison of IP address was wrong. I wasn't comparing the whole address, but I was comparing 1 byte. So basically, if you specify that at most 3 users from the same IP can connect, it meant that only 3 users globally can connect or something like that. So it happens.
Okay, so is NsJail somehow logging or displaying which actions it blocked from inside the sandbox? Like we disallowed dmask, like syslog,
yes.
Right? And can we from outside of the sandbox know about it, that somebody tried it?
Yes, yes, it can actually, it only works for the main process inside because that's the only process that you can wait for. If the process commits sandbox violation, you have chance to figure out that it happened, and NsJail will scream kind of loudly about that. In previous Linux kernel versions, you can actually read the syscall number that happened together with arguments. In newer Linux kernel versions, they removed this ability, actually for the reasons that I reported it to them, for totally different reasons than that, but the functionality is lost. But it will still tell you that your application behaved in the wrong way. But what you can do, console.
Here we go.
Typically, audit-D on a system is configured in a way that it will, show you events. So in here, you can actually, these are all those masks which were executed by us under the sandbox. Yes. So basically, you will get information what user ID, and you will also have information which kind of architecture. You probably remember that Genval was
also a syscall.
Yes, Genval was telling you that under Intel you can both run 32-bit and 64-bit applications, and even something called x32-bit applications. And yeah, we have syscall number. We have information whether it was x32 mode, which is crazy mode. You can read it probably somewhere. Something about that on the internet if you are interested. But this way. As well, NsJail will scream about it.
Okay, but I guess if it tries to request a file which is not in the namespace, the mount namespace, then we have no idea of knowing about it.
Yes, yes.
Which
When
makes
you
sense.
there are some interesting solutions to that. So I can tell you that maybe it cannot be done with NsJail or not with the current NsJail, but maybe you can put some fake file in there. Like for example, some bound, what's the name of that? Well, some bait, right? Bait file, like etc passwd. Typically you don't need it. You can put there some special device maybe. If actually somebody tries to open etc passwd and it shouldn't be openable, then you can maybe read this kind of event from outside the jail and then scream that wow, somebody opened etc passwd, your process shouldn't be doing that, something wrong is going on.
Okay. Can NsJail be used in Android?
Technically, yes. I'm not sure if anybody compiled it before, but yes, Android has the same syscall interface. It uses SE Linux as far as I know. So maybe SE Linux limits some syscalls, but conceptually, yes.
Okay, what about iOS? I guess the answer is to that question the same as OS X.
Oh no, I'm not sure. Is Seatbelt available under iOS?
No idea at all.
Yeah, different operating systems, different technologies.
Okay, does NsJail impact performance significantly?
It impacts somewhat. For regular users, for like Apache or something like that, it's kind of negligible. The bytecode inside the kernel is pretty fast. It's really simple. It's really fast. So you won't see that unless you really want to count, nanoseconds per syscall and so on. As for access to files, there will be some additional effort made by the kernel to map your file views, file paths inside your sandbox to outside paths. But it's also on the order of nanoseconds. I tested it with some big projects, and the results are so that I'm not sure if I saw any meaningful difference. Like even between runs, the processes run for different amounts of time and so on. So it's no bigger than with reasonably small syscall policy and reasonably small mount namespace, you won't notice anything beyond maybe 1%.
Okay, perfect. And the last question is, if we already have an application using like Nginx and Postgres or MySQL or whatnot, and it's already ready and we actually need to sandbox it now, are there any magical tricks except for doing it manually and preparing policies and whitelists by hand for the huge application? Are there any magical tricks like a NsJail learning mode, for example?
No, there is no NsJail learning mode. It would be kind of high level functionality. Something, if you're interested in doing something like that, creating automatically policies for NsJail, just let me know. We can work on that. But not available right now.
Yeah, fair enough. Yeah, so I guess my tip is like, if you're thinking about doing compartmentalization, then be sure to include it in the design level when actually designing the application. That is way easier than actually moving a ready and working application into any sandboxing solution, which is still possible, but there's a lot of manual work involved, and you have to like have some RPCs between them and so on, so it's complicated. Perfect, Robert. So thank you very much for joining me today.
Thank you for inviting me.
Yeah, I see we have a donation. Thank you, Paweł. So you're on the hook for actually telling me after the stream where do you want me to send the money. Thank you to everyone for the questions and for joining us. Yeah, Robert, I hope to meet you someday again, maybe about HongFast, your other project. Yeah, thank you. And I'm leaving you folks with, I guess, some things to think about and also with some music. See you either today on the tomorrow, we didn't pass the midnight mark. Either tomorrow on the Polish stream or next week on another English stream. So thank you once again, Robert. Thank you, KrzaQ, our moderator, and see you. Bye-bye. And
the whole